There is a powder that costs less than $2 per pound, turns dead, exhausted soil into one of the most productive growing surfaces on Earth. And it lasts for over 2,000 years without reapplication. Not a fertilizer you pour on once and reorder every season. Not a chemical amendment that builds a dependency into your soil and slowly destroys the microbial life beneath your feet. A permanent transformation. One application. Centuries of results. Archaeologists found it still working in Amazon soil that was last treated before Columbus was born. The global fertilizer industry generates over $230 billion every single year. The pesticide market adds another $80 billion on top. Soil amendment products, pH balancers, microbial boosters, nitrogen supplements, another $40 billion annually. Every single one of those products assumes your soil will always need more of them. Now imagine a substance that makes your soil permanently self-sufficient. Imagine something that builds the microbial ecosystem inside your ground so completely, but that it never needs to be rebuilt. Imagine paying $2 once and watching your soil outperform your neighbor's chemically dependent garden. That is not a fantasy. That is a documented, laboratory-confirmed, field-tested reality that has been growing quietly in the forest the entire time. This is the story of biochar, the ancient soil secret that Amazon civilizations mastered 2,000 years ago. The agricultural industry has worked very hard to keep this out of every gardening magazine, every home improvement store, and every conversation. Welcome to Fixvival. This is where we open the vaults they thought were sealed forever. Let me take you back to 1542. A Spanish conquistador named Francisco de Orellana pushes his expedition deep into the Amazon basin. He expected to find the savage wilderness his maps described. What he finds instead stops him cold. Cities, enormous cities. Settlements stretching for miles along the river. Populations that his chroniclers estimate in the millions. Cultivated land as far as the eye can see, producing food in the middle of what should be an agriculturally hostile environment. Because here is what every agronomist knows about Amazon rainforest soil. It is, chemically speaking, almost useless for farming. The nutrient cycle in a rainforest is entirely above ground. The trees hold everything. When leaves fall, that nutrition immediately feeds the roots. The soil itself, the actual dirt, is thin, acidic, and almost completely devoid of the organic matter that crops need to grow. Strip the trees and you have red clay that hardens in the sun like brick and washes away in the first rain. Slash and burn agriculture in the Amazon typically exhausts a plot within 2 to 3 years. Then you move on and burn a new section. And yet, Orellana was looking at permanent cities, permanent agriculture, populations that had been feeding themselves from the same ground for centuries. How? The answer was buried in the soil itself. A dark, rich, almost black earth that ran several feet deep in some locations. Terra preta. Dark earth. This soil was so different from the surrounding red clay that locals had a name for it for generations. When European scientists first properly analyzed terra preta samples in the 20th century, they could not explain what they were looking at. The microbial activity was off every standard chart. And the most baffling element? The soil was actively improving on its own. Left alone, terra preta spreads. It regenerates. It converts adjacent depleted soil into itself over time. For decades, researchers assumed the fertility came from organic matter, composted waste, fish bones, animal remains, the usual ingredients of ancient middens. Then they started carbon dating the samples, and the numbers came back wrong. The carbon in terra preta was ancient, thousands of years old, but it was not decomposing, it was not breaking down, because it was not organic carbon. It was something else entirely. It was char, biochar, charred organic material heated at low temperatures without oxygen, transformed into a porous carbon structure that does not rot or wash away. The Amazon civilizations had not simply composted their waste, they had charred it, deliberately, systematically. They had built a soil amendment so permanent that 2,000 years later, after civilizations collapsed, the dark earth was still there. Orellana had no idea what he was looking at. Neither did European scientists for the next 400 years. The knowledge of how to make terra preta was lost with the people who created it, or so the agricultural industry would prefer you to believe. Now, let me show you exactly why this works, because the science is genuinely remarkable. When you burn wood or organic material in a normal fire, complete combustion converts it to carbon dioxide and water vapor. The carbon leaves. It goes into the atmosphere. But when you heat that same material at temperatures between 300 and 700 degrees Celsius in a low oxygen environment, a process called pyrolysis, something completely different happens. The organic material does not combust. It transforms. The cellular structure of the wood breaks down. The volatile compounds escape as gases. But the carbon skeleton remains. And that carbon skeleton becomes a structure of extraordinary complexity at the microscopic level. A single gram of high-quality biochar contains a surface area of between 200 and 400 square meters. You read that correctly. 1 gram. The surface area of 4 tennis courts compressed into a piece of material you can hold between 2 fingers. That surface area is the key to everything. Soil microbiology is dominated by organisms so small that the spaces between soil particles are their world. Bacteria, fungi, archaea, the organisms that make fertile soil what it is, they do not live in the open dirt. They colonize surfaces. They build communities in protected microenvironments where they are not flushed away by rain or dried out by sun. Biochar gives them that environment in a way that nothing else on Earth can match. A single piece of biochar in soil creates millions of microscopic caves, tunnels, and chambers. Fungal networks thread through them. Bacteria colonize the walls. Beneficial microorganisms that would normally be flushed through sandy soil find permanent habitat. The microbial population density around biochar particles is orders of magnitude higher than in adjacent untreated soil, and here is where it becomes almost philosophically interesting. Biochar does not feed the soil. It houses the organisms that feed the soil. The distinction matters enormously because feeding requires continual inputs. Housing is a one-time investment. Add nitrogen fertilizer, and you get a nitrogen spike followed by a crash. Your plants eat, but the soil does not improve. Add biochar, and you build a permanent ecosystem. The fungi come. They pull phosphorus from mineral particles in ways plant roots cannot. The bacteria fix atmospheric nitrogen and make it plant available. Predator organisms arrive because there is now enough population to sustain them. This is why terra preta spreads. The microbial ecosystem it supports begins to transform adjacent soil, not dramatically, not overnight, but measurably, consistently, year after year. Beyond microbiology, biochar is a cation exchange powerhouse. Biochar's porous carbon surface carries a massive negative charge. It holds cations, nutrients that conventional soil loses to rain. Research in the journal Plant and Soil found biochar reduced nitrogen leaching by 50% in sandy soils. That is not a minor improvement. The pH effect is equally significant. Biochar has an alkaline character that slowly buffers soil pH toward the neutral range. And what is the life of the char? Carbon dating of Amazon terra preta biochar has returned ages of between 200 and 8,000 years. The carbon you put in the ground today will be structurally intact and biologically active long after every living person on Earth is gone. One application: permanent infrastructure. That is what the fertilizer industry is selling against. Here is the business problem in plain language. The Fertilizer Institute, the lobbying body for the synthetic fertilizer industry, represents companies with a combined annual revenue exceeding $80 billion. The pesticide sector adds another 40. Herbicide manufacturers another 20. The entire industry is built on one foundational assumption. Soil is a medium, not a system. Treat it like a battery. Charge it with synthetic nitrogen, phosphorus, and potassium. Extract the harvest. Recharge next season. Repeat indefinitely. If the battery degrades, if the soil compacts or acidifies, sell a corrective product to address that symptom while creating the next one. This model generates continuous, predictable, growing revenue. It is brilliant as a business architecture. It is catastrophic as a relationship with the land. Biochar threatens that model at its foundation, not because it replaces nitrogen immediately, but because it accelerates the process by which soil becomes self-sufficient. In 2009, a landmark study in the journal Nature measured long-term fertilizer requirements in biochar-amended soils over a 12-year period. Soils amended with biochar showed a 45% reduction in external fertilizer requirements. By year 15, synthetic applications were unnecessary entirely. A product that reduces your customer's purchasing requirements by 45% is not a product you market. It is a product that you marginalize, and marginalize it they did. Research funding for biochar in the United States represents a fraction of a percent of total investment. Extension programs do not include biochar in curricula. Gardening publications with fertilizer advertising relationships do not run cover stories about it. This is not a coordinated conspiracy. It is the invisible architecture of incentive operating quietly at every level of information distribution. Individual editors made decisions based on advertiser support. Extension agents passed on industry-sponsored training. Research committees funded projects aligned with industry priorities. The result is identical to deliberate suppression, achieved without any deliberate act. The knowledge exists. The science is irrefutable. The application is trivially simple and almost comically cheap, and almost nobody who grows food for a living has ever heard of it. But the knowledge did not disappear entirely. It found refuge in the places where knowledge always finds refuge when industry does not want it heard. In 2002, a Dutch soil scientist named Bruno Glaser published a paper in Natuurwissenschaften that reignited serious academic interest in terra preta. Glaser's analysis confirmed what observation had suggested for decades, that the fertility of Amazon dark earth was inseparable from its biochar content. The paper was cited by over 800 subsequent studies. An entire field of research, now called biochar agronomy, traces its modern origin to that single paper. By 2015, the peer-reviewed literature on biochar had passed 12,000 published studies, 12,000 papers confirming, refining, and expanding the basic finding. That charred biomass dramatically improves soil health, reduces input requirements, and sequesters carbon with extraordinary persistence. The International Biochar Initiative, founded in 2006, now connects researchers in over 40 countries. Australia has been the most aggressive adopter at the policy level. The state of New South Wales includes biochar in its carbon farming methodology. In practical terms, Australian farmers are being paid to improve their soil using a technique that Amazon civilizations mastered 2 millennia ago. The DIY community has been running ahead of the agricultural establishment for years. Forums dedicated to permaculture and small-scale food production have thousands of studies. Gardeners in the Pacific Northwest applying homemade biochar to depleted raised beds and watching them transform over 2 to 3 seasons. Small farmers in the Southeast reporting reduced irrigation requirements after heavy biochar application in sandy soils. Homesteaders in the Midwest composting biochar with finished compost, a technique called charging, and applying the combination as a single soil amendment. In 2019, a team at Wageningen University published a meta-analysis covering over 120 independent biochar crop yield studies. The analysis found a mean crop yield increase of 15 to 25% across all soil types and climates studied. In degraded tropical soils, the environments most in need of help, yield improvements reached 50%. These are not anecdotes. They are peer-reviewed, systematically analyzed, statistically confirmed findings spread across hundreds of independent research groups on 6 continents. And still, walk into any garden center in America and ask about biochar. Most staff will look at you blankly. Those who recognize the term will point you to a small bag of granulated biochar selling for $25 to $35. The material itself costs $2 per pound in bulk. The markup is extraordinary, and the market is tiny because the marketing is absent. Here's what you actually need to know, because the application is almost insultingly straightforward. You can make biochar with materials you already have access to. The simplest method requires a metal container with a lid. A 5-gallon steel bucket works perfectly, and a source of dry biomass. Wood chips, wood scraps, dry plant stalks, nutshells, bone, or any combination of these. You are not burning this material. You are converting it. The distinction determines the outcome. Dig a small pit in your yard roughly 18 inches deep and 12 inches wide. Build a wood fire at the bottom and let it establish fully. Once you have a strong bed of coals, begin feeding dry biomass into the fire in small amounts. The goal is to maintain combustion hot enough to drive off volatiles, but oxygen restricted enough to prevent the material from burning to ash. You are looking for the material to glow and smoke, not to flame actively. When the material has charred, begin smothering the reaction by covering the pit or dousing with water. This quenches the process and locks the carbon structure in place before it oxidizes away. What you have in that pit is raw biochar, porous, carbon-dense, and ready for activation. Raw biochar, applied directly to soil, will temporarily pull nitrogen away from your plants. This is the one mistake that frustrates new users. The solution is simple and ancient. Charge it first. Take your raw biochar and combine it with any rich organic material. Finished compost is ideal. Aged manure works excellently. Even a strong compost tea poured over the char and left for 2 to 4 weeks achieves the same result. The microbial life and nutrients from the compost colonize the char's surface area, filling it before it goes into the soil. When you apply charged biochar, it enters the ground already alive, already supporting the microbial community rather than temporarily starving it. The application rate for long-term soil building is 2 to 4 pounds of biochar per square foot, worked into the top 12 inches. This is a one-time application. You are not adding a treatment. You are installing infrastructure. For a standard raised bed, you are making a one-time investment that will benefit every growing season for the rest of your life. For container gardening, mix 15 to 20% biochar by volume. For established beds, top dress and work it in with a broad fork. In truly depleted or compacted soil, the transformation takes 2 to 3 seasons as the microbial ecosystem builds itself around the new habitat. Once applied, the char is there. It waits as it has waited in Amazon soil for 2,000 years for the conditions to return. One application, one investment, centuries of return. The Amazon civilizations that built Terra Preta are gone. Their cities vanished beneath the canopy. Their languages were lost. Their knowledge of medicine, architecture, navigation, and governance dissolved with them. But the ground they prepared survived. Not because they built monuments, not because they wrote things down. Because they changed the fundamental chemistry of the earth beneath their feet in a way that outlasted everything else they ever created. That is a particular kind of wisdom that our civilization has nearly forgotten. The wisdom of permanent investment. The understanding that what you do to the ground today will be inherited. by your children, by strangers, by people who will never know your name 2,000 years from now. The agricultural industry does not think in 2,000-year cycles. It thinks in quarterly earnings reports. It thinks in next season's product order. It thinks in the recurring revenue model that requires soil to always need something more. But soil does not need more. Soil needs less. Less disruption, less chemical flooding, less annual stripping and synthetic recharging. It needs the kind of infrastructure that living systems actually run on. Stable habitat, permanent architecture, the conditions under which microbial life can do what it has been doing since long before we arrived. $2 of charred wood, 20 minutes of your afternoon. The same knowledge that fed millions in a rainforest 2,000 years before the first synthetic fertilizer was manufactured. The industry buried this because they could not monetize permanence. They built a $230 billion annual business on the assumption that you would never remember it. But memory is a stubborn thing. The dark earth is still out there, still spreading, still fertile, still carrying the carbon signature of a civilization that understood something we are only beginning to rediscover. And now so do you.